joining still. And as Sam has already said, we're looking today at application lifecycle management with Visual Studio 2013. I'm really going to take you through a small number of slides just to give you an outline for what we're going to be doing today, and then take you through a series of demos using Visual Studio Team Foundation Server. And just to give you a bit of a heads up, we're actually going to be using Visual Studio Online. So we're going to be using Team Foundation Server that's running in the cloud. And the machines that we're going to be connecting to TFS up in the cloud are actually running in Azure. They are Visual Studio 2013 machines configured out of Microsoft's Azure gallery. And we have a couple of demo users to illustrate version control and working as a team, albeit quite small, but showing you some of the features and capabilities of Visual Studio that allow us to collaborate and work productively in the development of our software. So what are we going to be doing today? Well, as I go through the slides for you, you'll see there's a very short presentation. A little bit of housekeeping to start with. As Sam's already mentioned, we will be recording the session and we will be making that available to you next week. If you've got any comments or questions about the event, we've actually set up this dedicated email for you. If you include my name, which is on the screen again there, and you include the session name, which again I've shown you, you can have some feedback or make comments around the session that we can take on board for the remainder of this week and also for future tech weeks that we run. And as Sam has already mentioned, questions through the chat tool. Periodically, I'll stop if I manage to find some time to do that. We'll stop and answer questions that you might have. Anything that's technical as well, please raise it there, and Sam will hopefully be able to respond to you pretty quickly to address any issues that you might have. So, what is application lifecycle management? I have the feeling that if I asked all the people on the call today what they understood by application lifecycle management, we would probably end up with slightly different definitions from just about everybody there. Well, try to put things into context. When we write software, we really have been going through a very similar process for quite a long time now. Hopefully, we go out and we capture what the requirements are for our particular application or piece of software that we're writing. We may do that perhaps with a team of business analysts, or we perhaps do that for smaller projects, perhaps individually as developers. Perhaps if we're looking at what users want to get from the software that we're writing for them, we have to go out and understand what those requirements are. How we document those requirements, how we manage those requirements is perhaps many and varied, but we're going to be looking today at how we can use some of the tools within Visual Studio's application lifecycle management features to help capture and document and manage those. Perhaps once we've captured our requirements, we might look at some architectural modeling, or we might look at the structures and the types of features that we're going to include in how we write our application. And again, we may have used tools perhaps like Visio or Enterprise Architect for modeling out use cases or sequence diagrams, perhaps component models. We do some coding. So now it's time to write some code, and we test that code. Perhaps we run unit tests, we have regression tests, we have functional testing, UAT, a whole variety of different types of testing and testing tools that we perhaps use there. And we're really ensuring that our application is ready for build and ready for release. And of course, we go through that process. We decide that we want to build the product, we release it into operations, and then we start again. Perhaps we move on to version 2, and we also monitor the application once it's running in our operational context. That's not really application lifecycle management, though. That's just writing software. And sometimes we're good at that, sometimes we're not so good at that, sometimes we end up being late, sometimes we release without all of the features that we perhaps said we would have in the product, sometimes, horror of all horrors, we perhaps go over budget, and sometimes, of course, maybe we do all three of those things. Application lifecycle management is really layering additional functionality or additional capability around there, and it really layers 3 additional things on top of that software development process. The first of those is that we follow a way of working. We have a process, we stick to it, our team understand what that process is going to be, and the process can be anything that we decide. It could be an Agile type process, it can be perhaps a much more milestone driven process, it could be a Scrum type process, which of course is very popular these days. But it is a process, and our team understand how it works, and we follow that process during the development of our application. So we have some process layered on top of writing our software. We also need some kind of visibility. We need to understand what's going on. Project managers typically need to know how much work's left, how much work's been done, how many bugs are in progress at the moment, how many have been found, how many have been resolved, how many have been closed. We need to have visibility into what's actually happening in the development of our application. And that in the past has been quite hard to achieve. So we have a process, we follow that process, we have some visibility, we can see what's going on. The last thing that we really need to complete the story for ALM is that we need some traceability. We need to have an understanding of what's happened, why it's happened, who made it happen, and what the impacts of those changes have actually been. So that I can say, for example, that I've written some code, I can see that the code that I've checked in goes against a particular piece of work that I have to do. I can see that I've tested it, I've perhaps videoed the test and made that available. I've perhaps raised a bug, and I've then retested my fixed code, re-videoed it, and verified that the steps that I originally had that caused the bug have now been fixed. So traceability, looking into what has happened during the lifetime of our development, is another equally important part of ALM. So really we have those three things. We have a process, we have visibility of what's actually happening now, and we have traceability, in other words, proving what has happened in the past. Layer those three things on top of our requirements through to release cycle, and then we're really starting to talk about application lifecycle management. So we'd have these three additional areas that will sit on top of our normal development model. Okay, so where does Visual Studio fit with ALM? Well, a few years ago, 2005, I think, Visual Studio really came into the world of ALM and was designed from the ground up as a tool that would support the ideas of application lifecycle management. It doesn't sit on its own. It sits working with Team Foundation Server, with a product called Test Manager that we can use to plan and track and run our tests. And we have other features such as the feedback client from Microsoft that we can use to capture feedback from our stakeholders. Where does Visual Studio fit in the scheme of things with ALM? Well, the slide here shows you the Gartner Magic Quadrants, which came out in November of last year, and you may well be familiar with these, effectively positioning the capabilities of individual vendors in different areas of IT and technology. So this was the Magic Quadrant for ALM, and you can see there that Microsoft is right up at the top of this tree, and that really relates to the products that we've got on the left-hand side of this slide. I think what that tells you is that using Visual Studio and Team Foundation Server, you're actually able to really leverage the power of those products to give you the very best of ALM features. So what can we do? Well, we can do some work. Visual Studio allows us to manage our product backlog. In other words, the requirements, the things that we want to achieve. It allows us perhaps to work in an iterative way or a sprint-based way. It allows us to understand our progress via a series of dashboards and charts that describe and provide visibility into our product. We can collaborate together effectively using features called team rooms. We can storyboard ideas with products like PowerPoint. And we can get feedback on our software once we have it up and running using things like the Microsoft Feedback Client. So we can actually do some work, if you like, with the Visual Studio and its related products. We can design our functionality, we can model it, we can visualize our code, we can communicate information that's critical to the performance of our application using some of the modeling tools. And we'll look briefly at some of those later on this morning. As well as work and design, we can write code. We can share our code, we can build our code, we can see the history of our code, we can interrogate, if you like, what's happened during the lifetime of our code, we can compare it, we can collaborate together, and we can work with source code in a centralized way, perhaps in a Team Foundation Server type way, or we can work in a more Git type way with decentralized source code, depending on how you feel comfortable, perhaps the size of your team or the size of the application or product that you're working on. We can branch our code, we can merge our code. So effectively we can start from the simplest building blocks of what we're writing through managing everything about the lifetime of that code and the future versioning of it as it moves from one branch and one release to another. We can test. Testing, of course, incredibly important, whether that's simple unit testing all the way through to performance testing, stress testing, regression testing, UAT, functional testing, end-to-end testing, automated or manual tests. We can run them all using Visual Studio and Test Manager. And if we really need to, we can use Virtual Machine Manager from System Center and the lab management capabilities of TFS to allow us to deploy our finished or partly finished applications into virtual environments and test those applications under a variety of different platforms, whether that's different operating systems, different browsers, different versions of software that we have installed on the machines. And we can really start to identify and demonstrate where we need to apply particular fixes for different types of platform or environment that we might be working in. So we can plan our work, we can design our code, we can write our code, we can test our code. Well, of course, what we also need to do is we need to build our code. And those of you guys who already use Visual Studio, you may well press F5 to build your code. Nothing wrong with that. But what we can do with Team Foundation Server and the build functionality there is that we can set up separate build machines, separate on-premise build servers, perhaps more than one, perhaps many, perhaps not even in the same building, the same town, the same country as where we're actually writing our code. And we can configure those servers to build exactly what we want when we want to build them using things called build definitions, which we will see later on. Strangely, we can also do continuous integration builds, both on-premise and in the cloud. Team Foundation Server Visual Studio Online provides much of the functionality that we have on-premise through its cloud-based sister, if you like, that we're using in the demos that we do today. So really, with our capabilities from Visual Studio, from TFS, from Test Manager, from the feedback client, and so on, we can really take the complete development of our application from start to finish, all the way through from requirements capture, through modeling, through development, through testing, and into build and release. So how would we actually do that? Well, I guess that's where the demos really come in. And there's a couple of things that I need just to take you through before we start. I'm just going to share my desktop here. And if I just bring up one of my virtual machines. As I mentioned earlier on, I actually have a virtual machine running in Windows Azure. And it's a machine that's been configured with, as we can see here, Visual Studio Ultimate 2013. So all of the available features for Visual Studio and for TFS are available through this machine. And we are connecting from this virtual machine through to Visual Studio Online, where we have a demonstration account using Team Foundation Server effectively running up in the cloud. TFS, in this case, of course, not on the same machine as I have my Visual Studio running on here. And essentially what I have, and you'll get to recognize these different views as we go through, we have my first demo user. We can see up in the top right of the screen that this particular person's name is QA Demo User 1. Something rather strange about that name, but Demo User 1 for now. And we can see that that's quite a light theme in Visual Studio. I also have Demo User 2, who has a slightly darker theme. And of course, we can see up in the right-hand side, Demo User 2. And both of these users are currently connected to something called a team project, and a team project with the name of QA Demo. I'm going to talk more about team projects in a moment. But before I do, what I'm going to do is take you back to my first user, and I'm going to take you off to this web page. Now you'll see again here, this is a connection through to the QA Demo team project. Again, we will talk more about those in a second. And we can see that we are connected as QA Demo User 1. So what is a team project? Well, a team project is effectively a huge bucket that holds everything about our work in development and planning and writing code and testing our code and building our code, holds everything in a, if you like, a great big bucket of artifacts and work. This is really a web front end to that great big bucket, to that great big team project, in this case called QA Demo. And I can work with a web front end, I can work with Visual Studio, I could work with perhaps some Office products, as we'll see later on, to connect through to that team project. And the team project really is a crucial part of using TFS and using Visual Studio in a way that supports ALM. Now, when we create a team project, one of the very first questions that TFS will ask us about is how do we want to work? In other words, what process do we want to follow? And that process can be a process that we define ourselves. It can be a process that is pre-configured for us, if we like, that we can choose to use when we make the team project right from scratch. And it can be a process that we can customize as we're going along. If we're working in an iterative or sprint-based way, our sprint retrospectives that we would have at the end of each of our mini iterations would actually give us an opportunity to understand how we've worked in the previous few weeks, how we might work better, and TFS will allow us to change our process to support those incremental changes that we identify as better ways for us to work. When we first create a team project with Visual Studio, whether that's with Visual Studio Online or we're running with Team Foundation Server running on-premise, one of the things it will ask me is what process do I want to follow? And out of the box, you're actually given 3 processes that you can choose from. And again, you can make your own and you can customize these as you go along. And you're offered an Agile software development framework, and that's actually the framework that I've used to create the QA Demo team project, which we'll be working with this morning. And if I opt for this particular way of working, one of the most important things around a process, whether it's your own or whether it's one that's provided by Visual Studio, is that it allows you to identify particular types of work item that you want to use. The work item types really represent the different types of thing that can be created as artifacts to be addressed during the lifetime of the product and its development. So in the MSF for Agile software development process, we effectively have 5 major work item types. We have features, we have user stories, we have tasks, we have bugs, we have issues. Now there are some others which are illustrated at the bottom of this page, but these are our 5 main ones, and we would use features and user stories to identify requirements that we perhaps wanted to address during the development of our product. We would use tasks as things for individuals, perhaps developers, perhaps testers, and so on, to actually do during the development of our product. We would use bugs, clearly, for things that we'd identified that were perhaps not right with our product. And any kind of blockages, any kind of blocking problems that we have during the development of our application, we would identify as issues. And we can link those work items together, we can relate them together, we can hierarchically arrange them if we want to, in such a way to allow us to identify how many tasks are still to be done, how much work is there still to do, how many hours of time do we need to spend, how much work have we done, how many user stories are completed, how many have all their tests passing, how many have bugs related to them, and so on. So we can use these different work item types to really allow us to understand what it is that people need to do and what it is that people have done during the development of our product. In MSF for Agile, we have those core then 5 work item types. But as I just scroll across some of the other process templates that are available, MSF for CMMI has similar work item types, but you'll see here we have more of them. We have 8 of the core type, if you like, and we still have some additionals, which we'll talk about later. But we have features and requirements, but now we have change requests, we have tasks, we have risks, and so on. So CMMI tends to work in a slightly more, or can work in a slightly more milestone-driven way, and has these different work item types to allow that slightly more detailed, shall we say, view of our world when we're writing our products. So the CMMI process template also available as one of those that's a default from Visual Studio. The last of the three that come, if you like, boxed up with Visual Studio is Scrum. So we have the Scrum process template. And again, you'll see we have very similar work item types to perhaps the Agile process template. No great surprise there, I guess, with Scrum and Agile. But here we have features and product backlog items, which really represent our requirements. And we have tasks that developers will perhaps work on, and again, bugs and impediments for defects and issues that are blocking problems for us. So a variety of different work item types across each of the process templates. You'll notice in all of the three previous web pages that I've shown you, whether it's the Scrum one that we're on now, or CMMI, or the Agile software development process, we also have these blue and purple columns. The blue and purple columns really represent different reports that are automatically produced for us by TFS and different dashboards that are provisioned for us through, for example, a SharePoint portal or through the web portal for TFS that really allow us to grab hold of that visibility issue that we were talking about before, and also the traceability, to understand what's actually been happening as well as what's going to happen in the future with our reports. So all of those process templates provide us with those different features, whether they are work items, whether they are reports that we can view, or dashboards where we can see things. Now, there's a lot more to a process template than just work item types, reports, and progress. But I think that's probably enough for today. And this is something that if you want to get involved in TFS and Visual Studio and ALM, it's something to concentrate upon before you start. And actually, MSDN has some very good information in these three separate parts that I've shown to you this morning. But it's a good starting place. So understanding process, understanding how we work, and understanding its complexity and its tight integration with TFS, very important. There's something else that we probably need to understand before we start, and that's that if we're going to write some code, we probably need to have some sort of strategy for how we're going to manage the lifetime of our code, how we are going to release our products, how our developers work, how we want to isolate or secure the code base from different parts of our development team, and really try to identify a branching and merging strategy if we're going to use one for the development of our code. It's really important to try to get this strategy right before you start, or at least to get a good understanding of how you want to get it before you start, so that your team really understand how they are going to work as individuals, how they're going to be able to collaborate, and how the management of branching and merging of your code is actually going to be undertaken. Now, to help you here, what I've done is I've downloaded from Codeplex, which I'm sure some, if not all of you, have used. They actually have a TFS branching guidance document. What I've done is I've brought that document down to just talk to you about a few of the ideas that exist in there. Not all of the ideas, but again, it's something that you can go away and download and look at yourself. It's important to get a strategy right here. And really this has been produced by the group called the ALM Rangers, the Visual Studio ALM Rangers. And it takes you through some of the ideas about how you might write code and how you might undertake some ideas of branching and merging. And for those of you who are involved in development, you'll perhaps be very familiar with the idea that we'll have a line of development, a code-based line. In this case, we're going to call it main. And perhaps our simplest way of managing release of our product is for developers to write their code against artifacts held inside the main line of development. And as we get to each version of our product, perhaps label that code and then release based upon a label, so that we can build our code based against the version 1.0 or version 1.1 or version 2.0 label, and we can release that version of the code to our internal or external customers. So with no branch plan, we can very simply use TFS and its version control to allow us to release based upon a label. So that's one possible strategy that you could use, and there are many. Other possible strategies, if you look at having just a very simple release branch type strategy. So here again, we might be writing code against main, and as we decide that we are at a point where it's time to release a particular version of our product, version 1, version 1.1, version 2, and so on, we can actually branch the code away from the main line where we've developed and perhaps tested it into a new line, a release line, where effectively we don't really write any code anymore at all, unless perhaps we have an emergency hotfix that we want to apply to that version, which we can then merge back into the main line of development, as you can see on this slide here. And as we go through the lifetime of our product, we're effectively branching away from main to give us different releases of our application. So having a basic single branching strategy, we can have multiple versioned releases as we move along the main line of development. So that's another possibility that you might use. A third one, and this is the one that we're going to be using today, is actually to use a two-branch approach where we still have the main line, our code base that's in main. We don't write code in main. We use main for testing. We write code in the development line. And so our developers themselves will work with code that is stored within TFS, if you like, in a development branch or branches. And periodically, we can merge that code back from the development line into main, where we may perhaps take some functional testing, end-to-end testing, UAT, this type of idea, and do our testing against main. If we're happy with what we have in main, then again, we can branch out into our release versions, and we can still do the same things with hotfixes, merge those back into main, do what's appropriate with them when it comes to a development line. But we know that our main line is going to represent what we currently have in a release state. So that's the type of thing that we're going to be doing today. There are a lot of other branching and merging strategies. Again, if you go to Codeplex and download the TFS branching guidance, you'll find that there are lots and lots more slides within this deck and lots more information as well that will help you really make a decision about how it is that you want to manage your branching and releasing strategy. Okay, so essentially then we have a team project. The team project runs against a particular process, and we know now that we're going to have some sort of idea about how we are potentially going to be using a branching and merging strategy. And I've really taken you through those two starting points so that you can understand that when I go into Visual Studio, over on my right-hand side, I've got the thing called Team Explorer. Team Explorer is my view of the world from a team project perspective. Those of you who are involved with Visual Studio already will be very familiar with Solution Explorer. Here's Solution Explorer, very empty at the moment, haven't done much work. Solution Explorer, of course, is our view of a particular Visual Studio solution, in other words, a project that we are actually writing. Team Explorer is our view of the world from a team project perspective. The Visual Studio project and the team project are absolutely not the same thing. A team project is our big bucket that allows me to identify work items, to look at my source control and pending changes, to work with builds, to manage team members and look at the work that I'm trying to undertake as in my role as perhaps a developer or tester or whatever I am within the team. And you'll notice here that I am connected through Team Explorer through to the QA demo. I'm connected as the QA demo user one, and I can see that my URL for that is in my Visual Studio Online default collection for my project. Now, I mentioned the branching and merging because one of the things that we're going to do later is we're going to have to write some code. It's not going to be very complicated code. It doesn't need to be excessively complicated to see what we can do with Visual Studio, but we are going to write some code later. And one of the things we're going to have to do is, as it's highlighted here, we're going to have to configure our workspace, our source control workspace. And the reason I spoke to you about the branching and merging earlier on is so that you're going to understand when we configure the workspace and configure our source control structures, why it is that we're actually building out the folder and branch structure that we're going to be doing later. But for now, let's get started. Right back at the start of my slide deck, right at the start of the presentation, we talked about the steps towards writing an application, so requirements gathering, modeling, developing and testing and release. Well, all of those things are supported by Visual Studio and by other Microsoft and other products. Our starting point, I guess, is our requirements capture. How are we going to capture our requirements? How are we going to document those requirements? How are we going to work from those requirements to determine what it is that developers are going to have to do? I'm going to take you through a scenario today that really is almost the simplest it possibly could be, but I hope serves to illustrate the power of what Visual Studio and TFS can do. So we're going to actually be building out a really, really simple little DLL that does nothing more than just some basic mathematical operations. There's no need to build a complex MVC5 website in a demonstration like this. We can show what TFS and Visual Studio can do by having a really simple little project as well. So we're going to be building out just a very straightforward DLL. We'll write it in C#, but we're going to go all the way through from capturing what the requirements for that product might be, through to how we write it, how we test it, and how we eventually release it, and so on. So really taking you through the whole ALM processes, if you like. So our starting point then is to understand, going back to my Agile process over here. Yeah, the team project QA demo is actually based against the Agile software development process. And so really my starting point is going to be using my work item types to define what it is I want my product to do. In other words, to capture my requirements, to document those requirements, and see how I can use those requirements and those other work items to really start to allocate work to people. Features and user stories are really my starting point with Agile. So in previous versions of this particular process, we didn't really have features, we just had user stories. And user stories could be arranged hierarchically. Features are really big pictures, if you like, of what we want to achieve inside a particular product. And for something that's as small as a DLL, it's perhaps quite likely that in this particular case we're not going to have any features at all. Perhaps they're just too big. Perhaps my user story is big enough to represent the particular requirements that I might have for this component. For other larger projects, for example, if we were writing an e-commerce website, we might define features such as shopping cart feature or account maintenance feature. Really trying to bring together, if you like, a huge agglomeration of individual user stories that represent requirements of the shopping cart or requirements of the account maintenance functionality. For example, in a shopping cart, what would we want people to be able to do? We would want them to be able to add an item, remove an item, view an item, update the quantity that they want to order of that item. Those individual 4 things might be user stories. They are requirements for my particular product, but I could group them together into one overarching requirement, the feature, which would be the shopping cart feature. The same would be true of something like account maintenance. What do we want people to do? Create an account, close an account, update their personal details, and so on and so on. These would be user stories that could be agglomerated into the much larger account maintenance feature. And really what we're doing there is we're creating a hierarchy of work items that really represent a family, if you like, of parents and children and grandchildren and great-grandchildren that are all linked together in a way that allows us to understand how we are moving towards completing a particular user story or a particular feature. So using our work items is going to be our starting point. And because we're working in the Agile process, really I think for our simple little DLL, we can probably start with user stories. So how can I go about creating user stories? Well, there's a variety of different ways for creating user stories. And I guess one of the things that we have to think about is Who would want to create user stories? Who would want to create requirements? And that's quite an interesting question. I mean, who is it in your organization who actually is responsible for creating requirements and user stories, use cases? Do you have a team of business analysts? Are user stories done by product owners? Are they done by project managers? Are they perhaps even done by developers or lead developers? Who are they actually done by? Who are they created by? And the answer to that question really determines how you're going to document and create your requirements, your user stories. Business analysts, if they're dedicated business analysts, for example, may very well not have access to Visual Studio. It's not a typical business analyst tool. Many organizations, business analysts that I've come across would be perhaps terrified by using Visual Studio. They don't want to use that product. They perhaps want to use a different product. And we can do that in a moment. Perhaps if you are someone who uses Visual Studio and you're creating requirements, perhaps you want to use Visual Studio. And of course, the choice is there to do that too. And there's a variety of different ways that we could actually make these work items of all kinds, whether they're requirements or anything else. Well, the first way I could do that is I could go through Visual Studio. I could go into my team project, my team explorer here, and I could go to my work items. And in my work items, you'll see that I can create a work item. I can create features, I can create user stories, I can create bugs and tasks and issues. In fact, I can create only those kinds of work items that the process template, the Agile process template in this case, allows me to create. I can customize them, I can add different types of work item if I really want to later on. But for now, because we're working very much with the vanilla Agile template, I've really only got the ability to make those default work item types. There's a bit of a clue at the bottom here that I could also make work items with Excel, or maybe I can make them with project, and we'll come on to that later. So maybe if I'm a business analyst, actually what I want to do is I do want to make work items with Excel. If I'm a project manager, maybe I have project or I'm using Project Server, maybe I want to make work items using project. I can do that too. So I can do it in Visual Studio here. I can do it through Excel. I can do it through project. I can also, if I go back to my Team Explorer, I can navigate through to my web portal. Now, my web portal is, if you like, the web front end that I showed you earlier, this one over here. And this is the web front end for my team project. So this is like a web-based version of Team Explorer that allows you to do a lot more than you can do in Team Explorer. For example, there's a clue over here about things like the task board, which we'll see shortly. And what I could quite easily do here is I could create myself, again, brand new work items. And again, I can only make them of these particular kinds because that's what the process allows me to do. So again, I could make user stories from inside my web portal. But let's perhaps go from the route that we are a business analyst. We don't have Visual Studio installed. Perhaps we don't want to work from the web front end. Perhaps what we really want to do is we want to work with something as simple as Excel. Well, what I could do is I could just fire up Excel here. And because I have Team Explorer installed, and that would be something that you would have to do for someone to be able to use this next little bit of functionality. Because I have Team Explorer installed, if I go into my Excel, what you'll see is that I have my team menu here. The team menu is there because I have Team Explorer installed on this machine. And what I can do is I can go to my team node and I can actually create lists of work items inside Excel. So I don't have to use Team Explorer, I don't have to use the web portal, I can actually create those inside Excel. And when I do that, it will ask me, well, okay, so you want to work with Team Explorer, which team project do you want to connect to? And you'll see here that I can connect to my QA demo project. Excel will then say, well, what do you want to do? Do you want to use a query, which we'll talk about shortly, to base your work items against, or do you actually just want to enter a list of new work items? And we will come back to these queries shortly when we actually see the power of what they can do. But for now, let's just stick with a straightforward list of a work item that we're going to create. And you'll see here that Excel's intelligent enough, thanks to its Team Explorer integration, to actually say, well, okay, what kind of work item is it that you want to make? And again, I can create bugs and issues and so on and so on. Notice that I can also create these other work item types here. This is not because those work item types are unavailable in Team Explorer or through the web. It's because these can be made in Team Explorer from a slightly different area, which I'll show you later on, but they are still work item types that are identified, if you like, within the process template for Agile software development. So what we're going to do is we are going to make ourselves a user story. And as soon as I create that user story, Excel will update to say, well, why are you creating this user story and what's the state of this user story? And you'll see here that at the moment I can only say that this particular user story is new, and I can only have a reason that is new. And those rules, if you like, are imposed by the process template itself and actually describe how the user story can exist. That will change slightly. Who should we assign this to? Let's assign it to myself, my QA demo user 1, and let's create a title here. Let's call this something like component can undertake common mathematical operations. Okay, it's a bit of a strange title. It'll suffice for now, but it's clearly not something that I could give to a developer. It's too big. It's a user story. It's not a task. Once I've created all of my user stories, and of course the beauty of Excel, of course, is that I could actually create multiple user stories very easily by using the typical sort of drag and drop type techniques in Excel. Once I've created the user story, I can then publish it. I can publish it to my team project. First one always takes a little bit of time, but when I publish it, back will come an ID. And the ID is sequential. Each work item has its own unique ID, and I can identify the work item by its ID. So I could work in Excel. I can work in project in a very similar way to this. I've published my work item type. My work item. I don't need to bother saving the spreadsheet because I've published my data. And if I go back to my QA demos web page, if I look in my backlog now, as I go to my backlog, I can see that in the web front end, I've also got now my user story component can undertake mathematical operations. And I can see that I can add additional user stories here, and I can double click this, and I can start to implement more information about this user story. So when I look at this over here now, of course, I can see that my user story can be in a variety of different states. Its workflow allows it to move from new, perhaps to active, from active to resolved, from resolved to closed. Or perhaps if I don't want it anymore, I can set it to be removed. So I have a workflow, if you like, that exists for each and every one of my work item types and each and every one of my work items. I could also assign this work item to what are called different areas and iterations. And areas are typically functional areas, although I have seen them used by different organizations as perhaps geographical areas for their different development teams. Iterations are typically the sprints, the runs, if you like, of our development lifecycle. And so what I might do is I might say, I want to put this one on. I'm going to choose to do it. I'm going to choose to do this user story in the first iteration of my product, and I can say it now belongs in QA demo iteration 1. And for example, now let me just save this, and then if I was to, once it is saved, if I was to go to its history, you'll see that I can start to identify all of the things that have happened. So I made some field changes. It's like change to iteration 1. This is a typical example of the type of traceability that I spoke about right at the very start of the talk today. And you'll see here, I also have its current state. It's new. Now, of course, I could make it active and so on and so on, but I think you get the idea of how my workflow might work. Well, that's fine. We have some user stories. In this case, of course, we have just one, but we have some user stories. And now what we need to do is think about how might we actually implement that user story. And this typically may well not be the job of a business analyst. This might be more a job for someone like a project manager or someone like a technical lead, actually sitting down with the development team and deciding what actually needs to happen in order for us to complete that requirement, to complete that user story. Now, really, developers, they tend to work on tasks. They're much smaller atomic pieces of work. And it's no great surprise then that when we looked at work item types earlier, we talked about having tasks as a work item type. I could go off and create those tasks again through Excel. I could create them through Team Explorer in Visual Studio. I could create them in Project. I can also create them inside my web front end. And if I click on the Implementation tab inside my user story, you'll see here that I have the ability to either link to a work item or create a new linked work item, which will become part of a hierarchy of my work items that go to represent this user story. Okay, let's create a new linked one. And you'll see here that it says, well, how do you want to link as a child or a parent? What kind of work item type do you want to link to? Well, either a task or a user story. And again, the reason I can only have children or parents, task and user story, is because that's what my process says that I can do. I can't have a child that's a bug, for example. I could have a related work item type, that was a bug, but I can't actually have a child that's a bug. And I've just seen an interesting question just pop up on my screen about, can we use SharePoint to create work item types? Yes, we can. Yeah, absolutely. The functionality available in Team Explorer, through Excel, through the web portal, is also available through the SharePoint portal, where we can create work item types there too. Okay, so I'm going to make myself a child task. I don't know, what should we have here? Create multiply method. Should we start with the easy ones? Let's do add method. Okay, so we're going to have really simple little tasks that we're going to perhaps link out through to our developers. Now, the add method, of course, here will come, that's a task. At least it will be in a second. So here comes my task. And what I could do here, you'll notice that I can implement that as well. I can say that too has children or parents or whatever. And I could put a description in. I know it requires to be able to pass 2 doubles and return a double. And you can document that however you wanted to. And I could save this. I could obviously assign it to different people. I can say how long I think it's going to take. Perhaps it's going to take 1 hour. I've got 1 hour remaining. And this really is going to allow me to identify my task burn down. What's my burn down chart actually looking like as developers complete their work and say that they've got less time remaining and how much work they've actually done. So I can save this one, and very quickly, guys, I'll just make another couple. We'll just do create subtract method. And again, I think you've got the idea of this now. So I won't go through huge areas of actually putting in extra descriptions and so on. We'll just quickly knock together some of our work items. And again, we could be doing this in Excel much quicker. Hopefully my typing's working. Yes, it seems to be. Normally my spelling is atrocious. And I suppose we should have divide, shouldn't we? Got to give something for our 2 users to do. Okay, so now we've got really a hierarchy of our work items. We've got our user story, very simple one, and it's got 4 children that are all tasks that represent what it is we want the developers to do, and each and every one of those was in iteration 1. Now, what do I get through my web portal? Well, when I go to my work area here, if I was to look, notice that my backlog just shows me user stories, which is reasonable because that is that's a requirement. It's a backlog item. If I look at my board, Yeah, the board will show me. Okay, so here are my, or here is my my user story. If I go to my iteration 1, it will actually show me here are the things that were assigned into iteration 1. So I have my user story here. Notice that I could even create a task this way. So from my task board, I can even create a task here. I have the different states for my task, new and active and closed, and I can actually move the tasks from one area to another. Yeah, so I might say, what I want you to do is, Mr. Demo User 1, yeah, I want you to work on creating the add method. What I could also do is I could say I want perhaps Demo User 1, yeah, to also create the subtract method, and maybe I want, who should we go? Sorry, dropped that into the wrong place. Yeah, got to be very careful. Yeah, if I'm in my multiply method, I might actually reassign that into maybe Demo User 2. Okay, so now I've actually got some work that I want people to do. I've got Demo 1 and Demo 2, each with individual tasks to do. Now, of course, what we could do is our next stage would be, well, maybe we need to do some modeling. And the modeling side of Visual Studio really comes through some of our diagrams. I'm not going to take you through all of these today because we're relatively short of time, but I'll talk you through some of them. And of course, with something as simple as this little DLL, perhaps we don't need all of the documentation that we might go through. But through our modeling tools, we can actually create things like class diagrams, use case diagrams, sequence diagrams, and so on to really help us understand how it is we're going to model the finished application. We can use things like layer diagrams to really illustrate which components fit within which logical layer or physical layer of my product. And I can use those diagrams to validate the code that I write, validate the architecture, and ensure really that my code doesn't break the rules of my architecture. And I can look at the degree of coupling and cohesion that I've got between my different components. So some of the modeling tools are available through the architecture tab, but I would venture to suggest that for something as simple as I've got here, perhaps we don't need to do too much around those. So maybe we need to write some code. Demo User 1 and Demo User 2 have actually got some tasks to do. Yeah, they've got some stuff that they really need to get on with. Well, if they're going to write some code, then they need to be working perhaps with version control system. And to do that, they need to go away and configure their workspaces. And a question there just from John Dodd that's come up around some of the modeling tools. Yeah, the modeling tools are available from the Ultimate edition of Visual Studio. Yeah, absolutely. So my demo users, they're going to have to do some work. So they're going to have to firstly configure their workspace. And their workspace really is a definition of the mapping between TFS and its version control system and the local user's machine on which they're working. There are some very, very useful blogs out there from people like Martin Woodward around configuring TFS workspaces. In simple principle, very easy, but there are some elements of complexity that you might want to just have a read through some of their blogs, because they'll give you more detail than we can actually go through today. But I can configure my workspace here, or I could go into my Source Control Explorer, and you'll see that I have a workspace here that's actually called QA-TFS Demo. It says that it's not mapped, and what I could do is I could use my Source Control Explorer to actually help me map my content from the TFS machine, its version control machine, into my local filing system. Now, before we do that, just need to take you back to that branching and merging strategy we talked about before. And we have to recognize that if we're going to do some branching and merging, we perhaps need to have that kind of strategy in place. And the way that I would do that is that I would create myself some new content. At least I would do if I could. Okay, so what I could do is, sorry, I'm just going mad. Slightly strange, but never mind. My UI is not looking like I expected it to. Let me go over here just for a second. Let me configure my workspace just for a sec. And you'll see here that it's saying I want to point from the root of my project down to users, QA demo user 1, source workspaces, QA demo, etc. Clearly I can put that anywhere I like, but it makes some sense for me to do that here just now. So what I'm going to do is I'm going to map and get my content from my TFS machine, and you'll notice that it's now mapping, and my content here has become black rather than grey. And now I'm going to add my folders. What I'm going to do is I'm going to call this one name. I'm going to add another new one, and we're going to call that dev, as we saw in our branching and merging. And I'm going to add another new one, which we will call release. And you'll notice that they have these lovely little green check-in symbols. I've got pending changes. I'm going to go to the root here, and I'm going to check in my pending changes. That will bring up my pending changes window over on the right. I can put a comment in, because I'm a good developer. And I can check in. Now, it is possible to have check-in policies as well. So I can actually define rules that perhaps say certain work items have to be associated with a check-in, or tests have to run, or I can't check in unless my previous build is successful, and so on and so on. But each of my check-ins becomes a change set, and each change set has its own unique ID. In this case, change set number 10. I've now got my 3 folders. Well, folders aren't branches. Folders are different to branches. And so I can go to my main, and I could say convert it to a branch. I can convert it. I will get a slightly different icon. I'm going to start my project in main, and then I'm going to immediately branch it out into the dev folder, into a brand new branch that we'll perhaps call iteration 1. Okay, so effectively what I've got then is demo user 1, who we know how to do add and subtract, is now going to really start work. So demo user 1 is going to go to a new project, and notice that I'm working in this local path, which is C users, QA demo user 1, etc., etc., etc. What I want to do is build myself a really simple little DLL. So if I go through to my C#, let me build myself a really simple little class library. Let's call it maths. I could put it here. I could put it in this location here, users, QA demo user 1, etc., etc., etc. But if I'm going to have it under source control, then what I really want to do is to put it into this location that's my local working path for my workspace. So I can browse then through to my my source location. So I could go to my users, and I am demo user 1 at the moment, although I'm going to morph into someone else in a second. Source and workspaces, there's my QA demo, there's my structure. I can put it into main. We will select that one, and now we're mapped here, and I'm going to create a little directory in a folder called maths. So we'll add those in. The project is coming in nicely. We're not really going to write too much code in here because, as we said before, we don't really write code against main. We're going to write code in dev. So what we're going to do is we're going to immediately branch our content, even though it's very simple. We see our content here. Even though it's very simple, I don't really want to do any work there. What I really want to do is just check in. And check it in. That, of course, will become change set another number in this case. And what I've got now, of course, is I've got my content here, and I've got my locally mapped work as well. You'll see that it's also possible for me when I check in to link check-ins to work items. And that's really very useful because what it does is it allows me to indicate that a work item has either been finished or is just linked with a particular change set, a particular set of code. And that gives me a much tighter linkage between my understanding of how my task is going and the code that's associated with that particular task. Okay, now what I'm going to do is I'm going to branch main now. We're going to branch, but we're not going to branch into the main branch. What we're going to do is branch the latest version, although notice that I could branch any kind of version I like. I'm not going to branch it there. What I'm going to do is I'm going to branch it into my development line, and we will call it iteration 1 because that's our first iteration. We'll branch it away. It's a single action. There's no pending changes created in that case. And of course now my local path is pointing at a different location here. And what I could do as demo user 1 is I could get my latest version, and I could go and work on that version, and we could actually do some work in the class file. Over in Solution Explorer, of course, now I will have my class 1, I've got my maths project, all locked up nicely in source control. And you'll see here that I've got a window that will show me what kind of pending changes there are and who's currently got that file checked out or is working on it. Now, it's a little unfair at the moment that demo user 1 really has been doing everything. So very quickly, I'm just going to nip to demo user 2. Here's demo user 2. Demo user 2, again, doesn't have their workspace configured. So we're very quickly just going to go and configure my workspace. Again, it's going to point at demo user 2. We're going to do a map and get. And of course, what we'll see here is that in my Source Control Explorer, demo user 2 will now have access into the team project's source code. So I go over to my source control view, then of course, here we are, demo user 2. When they look at dev and iteration 1, they're going to be working at this location, but they still have access to the same code base as demo user 1. Okay, so let's very quickly just go back as demo user 1, and we will go into class 1, and let's write some content. Let's have something really simple, obviously too complicated for my typing. Let's have something like this, because we had to do the add method, didn't we? Yeah, let's do something really, really simple. And let's have. Now, I know the exception handling is not great, and there's not an awful lot of comments, and it's not an overly well-tested piece of code, but it serves to illustrate a purpose. I could now then go back from here, and it says that it's checked out to me. I can check it in. Yeah, I can save my local copy, and if I want to, I could go here. If I had some personal queries, then I could run a personal query, or I could add work items by ID to actually link this particular check-in through to that work item. Now, interestingly, if I was to go and look in my work items, and I was to look in my queries, you'll see that I've got my tasks. And if I look in my tasks, it will show me tasks that are assigned to me. So, for example, the add method, the subtract method, and so on. I can actually drag those tasks up into my work to allow me to identify what it is that I'm currently working on and to suspend that work or ask for feedback. So some really nice features there in Visual Studio that really allow me to very easily see the work that I've got to do. But for now, I can say that I want to link this particular check-in through to work item number 2. So I can go back to my Solution Explorer, I can check it in, I can then say, well, add work item by ID, let's just say it's number 2, we'll add that in, there's my create method. If I want to, I can say I'm either associating or I'm resolving that task, in other words, moving the task away from its active state through to its resolved state. I will resolve it, and we'll say completed. Silly little comment, but it'll do for now. There we go. Oh, let's try that again. Completed. Yeah, and check it in. Okay, so life's great. We've managed to check that item in. It's now associated with work item number 2. And if I was to go back to my work items and I was to run my tasks again, you'll see that work item number 2 has disappeared from here because it's no longer active or new. Yeah, it's actually moved to the resolved state. And if I was to go back to my work portal and I was to go to my task board again, so go off to my board, you'll notice that the create add method has moved automatically into its closed state because it has been resolved by my check-in. So some good news there. Okay, so still as demo user 1, maybe what we want to do is let's do a little bit more work because we've got the subtract method to do. So again, we'll just copy this Yeah, we'll rename it to be subtract. Much easier to work this way. Yeah, and we will say it's x minus y. The code is checked out to me. That's great. But whilst we're busy doing subtract, perhaps what we should do is before we check in, let's go and have a look for demo user 2, and let's grab hold of our content from our first iteration. We'll go into our Solution Explorer, and we should see that class 1 is currently checked in. And I can look at class 1, unless I actually open that in the wrong place. We do a get latest on it. Okay, much better. Yeah, there's my add, so I can see that I've got that version of my code. Okay, I too could start typing. And we know that we've got the multiply to do. So I can add in multiply, and we could check that code in. And we've seen already that checking the code in, I could associate work items and so on and so on. I'm not going to take you through that process because we're going to be short of time if we're not careful. But you know now that you can. Yeah, and we will check that in. So demo user 2 has now checked in that code. And of course, demo user 1 is going to continue to work. Use demo user 1 again. And type of demo user 1's check in. It's obviously a busy day at the ranch. Save my local copy and try and check in. And at this point, I get a problem. And I get a problem, of course, because there's now a conflict between what I'm trying to check in and what exists over on the server now because of demo user 2's work. And I really have some choices. I can take the server version of it, replacing my local copy, or I can keep my local copy overwriting the server, or I can merge changes in a merge tool. And you don't have to use the Visual Studio merge tool, but it's the one that's clearly provided with Visual Studio. There are other tools that you can use. And we can simply now, we can look at what is in change set 14, what's over on the server, yeah, what's in my local version. Well, this is my local version. Yeah, and what will be the resultant version if I select the different areas of my code. Now, I'm quite lucky because I am both demo user 1 and demo user 2, so I don't really have to have a conversation. But of course, this would be where your developers would be speaking to each other, hopefully, yeah, to determine what it was that had to be accepted as a merge. Okay, I can accept my merge, which is kind of nice, and then I can check in. And now change set 15 has been successfully checked in. All of that's rather nice, except for the fact that if that's all the version control system could do, that would just be quite a good version control system. What I can also do is, if I go into my source control, I can do a lot more than just this. You know, I can annotate, for example. So I can look at my code and I can see in a read-only version of my current code, I can see each of the individual change sets, who checked them in, when they checked them in, and what lines of code were actually associated with there. And I could drill down into the change set details to see more detail that was involved in that checking. I can see a history. You know, so if I go to my history for this particular code, you know, I can see every single change that was ever done, yeah, using this particular history viewer. Okay, so there's a lot that can be done with source control. We haven't talked about shelving, but I'm conscious that we only have around about 20 minutes left. One of the things I can do with shelving is to, rather than check my code in, I can put it on like a library shelf, and I can allow other people to take my code off the shelf. It's not in version control, it's just in source control, and I can allow people to modify or rework my code if I'm interrupted or if I perhaps want to hand off my work to someone doing test, for example. Okay, so talking of test, there are a variety of testing tools that we have. Yeah, I could go into my test, and you'll see here that I have a variety of windows. My main one is Test Explorer. Yeah, Test Explorer and code coverage work hand in hand, but the Test Explorer allows me to work with testing functionality inside Visual Studio. So maybe we should write some unit tests. That might be a good idea. I can't see that the test should fail, but let's write some unit tests. So if I go to my solution, let me add a new project. And you'll notice in Visual Studio that we have these testing projects. So for web performance, load testing, coded UI, and again, all of these are test types that are available for the ultimate versions of Visual Studio and Test Professional. If I go to unit test, let's call it math tests. And we'll keep it in the same location. We'll keep it under source control as well, which would be nice. That's a good idea. We've got our tests under source control as well as our code. And you'll notice here that I get my new project. I'm going to reference my maths project because I think that would be sensible if I actually want to test it. And I'm going to create a method here. This is the add two numbers test. What I'm really going to do here is I'm going to create my very simple unit test for my add method. Okay, so to do that, what we're going to have to do is understand that my test is going to call the add method itself, and so I'm going to have to pass it two values for x and y. I'm going to have to call the method, and I'm going to have to get the answer back and compare that with what I think it should be. So what am I going to have? I'm going to have double x. Let's give it a value for now. Interestingly, what we can do is, whilst I'm just typing this, is we can data drive these tests. We can actually say, I want the data to come from a database table, or I want it to come from an XML file, or I want it to come from, well, pretty much anywhere I like. It's just something that we can do to actually pump hundreds or thousands or millions of rows of data through into my unit tests, rather than having to have the developer manually changing all the values. Okay, so what I've got is I've got my x and y and an expected value, and my actual is actually going to be a call out to the maths, and we had class 1, didn't we? And we had an add. Ooh, Adrian's been very remiss. And let's put those in. Okay, let's check those in again. Do apologise, guys. Okay, so let's go back into my unit test again. Notice, of course, they're under source control 2. And with a little bit of work, I've now got my add method. That's much better, isn't it? Of course it is. Yeah, notice that my method here is expecting its x and y's, and so I'm making a call to that method. Yeah, where actual equals that. And what we could do is we could then use our assert class, to say are the expected and the actual what we expect them to be. Yeah, so expected is 10, and my assert statement is effectively going to be how my test is either going to pass or fail. Okay, so now going to my Windows, if I build my project, if I go to my test windows, I can go to my Test Explorer. There we go. I can look in Test Explorer, and I can see now that I've got my add two numbers test, and none of you guys will be at all surprised to know that if I run my not run tests, then my test will pass. No great surprise there. But as I say, I can have as complicated a unit test as I like, as many different test methods as I like, and of course I get it, guys, that it's a very simple unit test, but it's a very simple method. I can also, as I go through here, if I look in my Windows, my Test Explorer is really my area where I'm going to get the most benefit from everything that I'm doing in testing, and I may well have a series of tests that will run down here, and I can see which have passed and which have failed. This is not the same tool as Test Manager. Test Manager is another tool that exists in the suite from Visual Studio that is absolutely about planning your testing efforts, using test case work items, running those tests, and is a little bit outside the scope of what we're talking about today, but is certainly something that's out there for common consumption these days. Okay, so maybe we've done some testing. Maybe we'll check in our code. Maybe it's now time for us to do some build. Okay, well, how is build done? Well, again, build could be done via my Team Explorer. I could do build. Yeah, I can do build here. Yeah, and I can create what are called build definitions through Team Explorer. I could, if I wanted to, go to my web portal, and using my web portal, I could go into my build, and what I could do is I can work with what are called build qualities to define the standards, if you like, of build. I can manage my security. Let me go back into Visual Studio for a second, and what we'll do is we'll go into my build, and we will create a new build definition. And the build definition really is the thing that defines how and what you want to build, when you want to build it, where you want to build it, and so on and so on. Now, if I say my build definition, let's call this simple maths. Okay, my trigger in this case is going to be just a manual check-in. Yeah, so I'm just going to, I'll rephrase that. It's just a manual one. The check-ins don't trigger my build. Tripping over my tongue now. So really, a developer is going to have to manually start off the build process, or perhaps your release manager, or someone responsible for build. But I have a variety of other build types too. So CI type builds, rolling CI, gated check-ins that are CI, but check-ins only happen if the merge and the build is successful. So we avoid breaking our build, scheduled builds. We really have complete flexibility about what it is that starts the build process. I'm going to have a manual one just for now. Our source settings really says where is it that we want to get content from, and how are we going to refer to a directory on the build agent machine, the machine that's going to do all the work. How are we going to refer to that location if we want to customize our build process? Does the build work using a hosted build controller or an on-premise build controller? There you'll see here that from my drop-down I've only got hosted. That's because I'm actually attached to my my Visual Studio Online. Yeah, so my hosted build controller is actually going to do the build for me up in the cloud. You know, copy the build output to the server. Well, if I'm doing something on premise, then basically I could say it doesn't copy, or it does copy to a UNC path, or et cetera, et cetera. But in this case, I'm just going to copy to my server. In my process, this is what do I want to build. Yeah, so basically what I can do here is I can say, what are the things that you actually want to build? What projects? And I could say I want different configurations. I want a debug build, or I want a release build. I want a particular platform. Let's go for any CPU. Yeah, or if I want multiple platforms, I can do that too. Yeah, so I can really start to say what it is that I want to build. You'll notice here that it will say, well, do you want to run tests? Well, yeah, I do actually. I want to run my unit tests. And because of my cunning naming of my math test project, it will run the tests that are in projects that match, if you like, the file pattern, which math tests actually does do. Yeah, although we could change that, obviously. I have a different build number format if I want. I can really start to say, perhaps in advance, that I don't want to work, for example, just against the current version, not the latest version. Maybe I want to build against the label, or maybe I want to build against a change set even. So I can say I only want to build up to change set number 10, for example. You'll notice that if my build fails, by default, it will actually make me a bug to say there's been a build failure. So there's an awful lot of settings that we can really start to work with and customize inside the build definition. Work with build is a bit of a black art at times. But the build definitions really do give us an opportunity to customize these as workflow processes. I've got my retention policy. How many builds do I want to keep that have passed, failed, partially succeeded, so on and so on. With CI builds, or manually kicked off builds, or even private builds that are running locally. Okay, so my simple maths definition and my build definition will save him. There he goes as simple maths. And what I could do now, here's my simple maths over here. Yeah, and what I could do is I could actually queue the new build from here. Yeah, I can also look at my build controllers and see what's working with those. I can edit my definition. Yeah, I can queue my build though. It asks me one last time, what is it that you actually want to build? Do you want to pass any more parameters through to your build machine? In my case, I don't. And I'm just going to queue the machine, queue the build machine, and we'll kick off the build. So it says it's in the queue. Let's see what's happening with him. Yeah, let's go over to my queues. I can see that my simple maths is here, and you can see that it's queued and ready to go. So it's in the queue. It's been queued for 12 seconds. Whilst that's happening, I've just had a question that's come through from Mark Forster. Can you do a build when you are not using a .sln? Our code is VB scripts with no project files, and the build process is copying the source to deploy. I assume by default it's using MS Build or something similar. Yes, absolutely. MS Build is the core, if you like, of TFS Build. It's based around building of SLNs, but it is possible to customize anything that you want to achieve. So yes, if you're copying content from source to deploy, then yeah, yes, you would be able to do that. Okay, it looks like my current simple maths, which is simple maths 2014 0424.1. It's my pleasure, Mark, by the way, is now currently running. And you might think, well, it's taking quite a long time to run, but the first one's always a bit slow, and of course, this one's running up in the cloud, so it's going to take slightly longer than perhaps if it was running on premise. But you'll see that the machine's now running. It's telling me what's happening. I'm running the MS Build for my project. It's going to run its tests. It's going to do its compilation. It's going to do all the work. And hopefully, if my code wasn't broken and my build succeeds, it will drop its output through to the build server. Whilst that's going ahead, guys, I think we've got about 5 minutes left. There is an awful lot more to ALM and Visual Studio than we've been able to cover in an hour and a half. But I hope you've had a bit of a flavour of what we've managed to achieve or what we can achieve. There are lots of other products out there, Feedback Manager, Test Manager. Obviously, you need people who do things like administration of TMS if you want to get involved in this sort of thing. There's a lot to go at when it comes to ALM and Visual Studio. But I hope you've got some sort of flavour for what is possible. Okay, my build is coming along nicely. And finally, my build has run. So for 101 seconds, yeah, the hosted build controller has actually told me as well, yeah, that my test run has completed. Here is the results of my test. I have a 100% pass rate. Wow. I didn't switch on my code coverage, but if I had, then I could see my code coverage results. It's told me that everything's compiled. I can see my log. Yeah, I can open up my drop folder. That would be quite funky, wouldn't it? So, you know, we talked about dropping the source to the server. Well, of course, the server's up in the cloud. Yeah, so here I can actually say, download the drop as a zip. Yeah, down comes my zip. I can save it onto my desktop, for example. And that is what CFS has actually managed to build for me up in the cloud. And here's my simple maths. And inside here, I've got my drop. Here's my DLL. Obviously, I've got my PDBs as well. And here are my maths tests to go with it. Not a particularly functional DLL, but it does what it said on the tin. Okay, guys, it's been my real pleasure to be here. I hope you've enjoyed what we've done today. I hope it's been worthwhile for you. If there are other things that you need to know around ALM, TFS, Visual Studio, then I'm sure here at QA we'll be able to help you. Okay, just one last little bit of housekeeping for you at the end. Remember, it has been recorded, and I know the wonderful Sam will be letting you have that later on. If you have got comments or you've got queries, anything else, techweek@qa.com. Make sure you put my name, it's again on the screen there for you, and the session name, and it'll make sure that it's routed through to the correct person to answer some questions for you. Okay, I hope you've enjoyed the session. It's been a pleasure having you here, and hope to see you all again. Cheers now. Bye-bye.